Here are a few examples of solving a system of equations by elimination. First of all, remember that elimination means that you're trying to eliminate one variable. It's also called the method of addition because you want to add the two equations together. Remember that when I have an equation, I have to keep it balanced by adding the exact same thing to both sides of the equation. So, for example, in this first one, if I want to solve this system, I'm going to multiply the second equation by 2 on both sides. My first equation stays the same. My second equation now becomes 2x minus 2y equals negative 6. Now if I add these two equations together, the y's will drop out. I can do this because I'm maintaining the equality. I'm adding to the left-hand side something that's equal to the right-hand side. So for example, just like when I would solve this equation by subtracting 6 from both sides, the negative 6 is equal to negative 6. So I can do that. It maintains the equality of the equation. In this case, I'm adding 2x minus 2y to the left-hand side, and I'm adding a negative 6 to the right-hand side. Those two pieces are equal though, so I'm maintaining the equality. On the left-hand side I have 4x, on the right-hand side I have negative 2. When I solve for x, I get x equals negative 1/2. That's only part of my solution. Now I need to substitute it back in. So I'm going to choose to substitute into the first equation. 2 multiplied by negative 1/2 plus 2y equals 4. 2 multiplied by negative 1/2 is a negative 1 plus 2y equals 4. Which means 2y equals 5, which means y is 5/2. My solution is negative 1/2 comma 5/2. That's the point where they would cross if I were to graph them. Because this system has one solution, one point where they intersect, it is called a consistent system. It has one solution. Moving on to something a little more complicated. Now I have 5x plus 3y equals negative 3 and 2x minus 7y equals 7. Now in my first system, I was able to multiply one equation by 2 in order to focus on the y's and get those to drop out. In this case, I can't really do that. So I'm going to multiply both equations by something. I'm going to multiply the first equation by negative 2 and the second equation by 5. When I multiply the top equation by negative 2, I have negative 10x minus 6y equals a positive 6. In the second equation, I have a positive 10x minus 35y equals 35. Add these two together. Again, my x's are the variable that drops out this time, and I'm left with a negative 41y equals 41. Divide both sides by negative 41 and you get y equals negative 1. Again, that's only part of your solution. So now I substitute back in. You can use either equation, 5x plus 3y equals negative 3, or you can use 2x minus 7y equals 7. I'm going to use the second equation this time. But again, it doesn't matter. So now I have 2x plus 7 equals 7, which means 2x equals 0, so x equals 0. My final solution then is 0, negative 1, which again means it's a consistent system because I have one solution, one point in which they would intersect. Alright, the last example. Now let's say I want to get rid of the y's. So I'm going to multiply the top equation by a negative 2 so that I get negative 4x plus 2y equals negative 12. The bottom becomes 4x minus 2y equals a positive 1. And now when I add these two together, both the x variables and the y variables drop out. On the left-hand side, I'm left with 0, and on the right-hand side, I'm left with negative 11. Now you've got to think to yourself, I've got a problem. 0 doesn't equal negative 11. You're right. These lines are inconsistent, which means there's going to be no solution. This is an inconsistent system, I should say. The answer is no solution. Now, if you were to solve something, and you would get 4 equals 4, for example, or something else that's true, that means it's a dependent system. And remember, that means there is an infinite number of solutions. If I were to graph a dependent system, that would look like a line with the other line right on top of it. If I were to graph the inconsistent system, that would look like two parallel lines. Maybe they don't have a negative slope, but they'd be two parallel lines.